At STP, the volume of a gas is 6.3 liters. What is the pressure of the same gas at 7.8 liters and 340 Kelvin? Let's write down our information. At STP, this is giving us the temperature T and the pressure P. That means we're going to have a T1 temperature standard is 273 Kelvin. And a P1 pressure standard is 1 atm. This goes along with, because it's in the same portion or the same part of the sentence, the volume of 6.3 liters. Then they ask, what is the pressure, a new pressure, so P2 equals question mark, of the same gas at 7.8 liters, that's a volume, and 340 K, that's a temperature. So just to double check, our temperature units match up and our volume units match up, and we're in the temperature units of Kelvin, so that's good. We don't have to do conversions. What kind of problem is this? Well, we're gonna have a dynamic gas law problem. So we're gonna take our first group and PV equals nRT. This is one ideal gas law. This is our 1, 1, 1, 1, 1, but we don't have everything. There's some things missing here. We don't have our moles, so we're going to cross that out, and we don't have our R. Our second group, PV equals nRT, 2, 2, 2, 2, 2. Again, we don't have our moles or we don't have our R, so we cross those out. Now we have left P1 V1 equals T1 and P2 V2 equals T2. We can divide both sides of this equation by T2 to cross that out. Divide both sides of this equation by T1 to cross that out, and now marry these two together. P1 V1 divided by T1 equals P2 V2 divided by T2. This is the combined gas law, but again, we don't need to know it. Now we can plug in our numbers if we would like. P1 is 1 atm times V1, which is 6.3 liters, divided by T1, which is 273 Kelvin, equals our P2, which we don't know, so we'll leave as P2, times our V2, which is 7.8 liters, divided by our T2, which is 340 Kelvin. Now we want to get the P alone and in the numerator on one side of the equation. It's already in the numerator, so we don't have to worry about that. Let's just get it alone. The way we do that is we want to get rid of all the numbers and the units on this side. So we're going to counter them by multiplying both sides by 340 Kelvin. That gets rid of these. Then divide both sides by 7.8 liters. That gets rid of those guys. Now we're just left with P2 equals everything here. If we use our calculators, 340 times 1 times 6.3 divided by 7.8 divided by 273 equals pressure 2 equals roughly 1.01 ATM, because our liters canceled out, our Kelvin canceled out, and we're left with this ATM, which we put in our answer.